Okay. So your first question in Delta Math looks exactly like this first question. So we're going to write some things on our journal. So I'm just writing this. This is on the front cover. So on the front page, the larger fold over piece. So if I think about my piece of paper that's folded over, this is where I'm writing this. I'm writing this right here on this piece. Okay. So we're going to write some notes. So the first thing I want you to do, because you're going to put this in your journal, is label it 5.6 graphing inequalities. Refresher. Okay. So graphing inequalities refresher. I want you to remember some things that you learned in lesson 4 when we did linear inequalities, probably 4.7, I think, is what it was. I need to switch spots with these. I want this one to go here and this one to go here. Okay. All right. So we're going to review. So the first thing that we're going to do is solve and graph one variable inequalities on a number line. So these are one variable inequalities. We're going to solve them and graph them. So example number 1, 5x plus 17 is greater than or equal to 52. 5x plus 17 is greater than or equal to 52. Remember that we solve inequalities just like we solve equations. There's only one, well, there's like two special rules, and we'll go through both of them as we come to them. So we solve inequalities just like we solve equations. So the idea is to isolate the variable. We're trying to get the variable all by itself. What is the first thing that I should do? Subtract 17 from both sides. Yes, sir. So let's do that. So I'm going to subtract 17 from both sides. So 5x is greater than or equal to 35. What is the next step? Yes, sir. Divide both sides by 5. X is greater than or equal to 7. Now I want to write a little note here. When you have a greater than symbol or a less than symbol, your graph is going to have an open circle. When you have a greater than equal to or less than equal to, your graph is going to have a closed circle. Okay. The other thing I want to tell you is that you shade in the direction that the inequality points. But there's something special about that. The variable must be on the left side. So I'm going to wait for you to write that down. So draw your symbols: greater than, less than, open circle, greater than, equal to, less than, equal to, closed circle, and then write the note that we shade in the direction that the inequality points, but the variable must be on the left side. So we have the solution: x is greater than or equal to 7. I hope that you guys remember doing this. We did solve inequalities. So we're just going to draw a number line. Remember, I only use the number that we're talking about. We're talking about the number 7. The symbol, the inequality symbol, greater than or equal to, does that mean that I'm going to have a closed circle or an open circle? Does this symbol, I heard someone say closed. Yeah, this symbol means it's going to be closed. Which way is that inequality pointing? Which way is that arrow pointing? If you think of that inequality as an arrow, which way is it pointing? It's pointing to the right. Okay, so we're going to have a closed circle, and we're going to shade to the right. So if x is greater than or equal to 7, that means that I want all of the numbers that are bigger than 7 or equal to 7. That's what that means. Okay. So over here, my inequality notation, x is greater than or equal to 7. And then on the number line, I am going to plot a point at 7. Maybe click and drag to plot the line. Well, I need some help with that because I think oh, there we go. Gotcha. Perfect. So you're going to put a closed circle. I'm sure that if you click on that, it'll make it open. Closed circle, and we're shading to the right. If I click on this, it'll probably move it over to the left-hand side, but we don't want that. Okay, so close circle, shade to the right. Submit your answer, and let's go back to the next one. So I'm going to go to problem number 2. So this is question number 2. So question number 2, again, this is just a review. 3x plus 17 is less than 26. So ideas on how we would solve this. What do you think, Brianna? What would you do first? Yes, ma'am. Subtract 17 from both sides. All right, Victoria, I have 3x is less than 9. What would you do next? Divide both sides by 3. So x is less than 3. So when I think about my number line, is this going to be an open circle or a closed circle? It's going to be open. Am I shading to the right or to the left? Good job. So open circle, shade to the left. I'm just going to add the number 3 down here. I don't know why that shading just doesn't want to stay. Ugh. There, shade to the left. So over here on your inequality notation, x is less than 3. I'm going to drag that to the positive 3, open circle. Are we good with that? So I started over here and I kind of drug it backwards and then click on it to make it an open circle. Go to question number 3. Question number 3. All right, question number 3. Negative 5x plus 3 is greater than or equal to negative 22. Negative 5x plus 3 is greater than or equal to negative 22. So what do you want to do first? Kylie, if you were going to solve this, what would you do first? Help out, Ariana. Subtract 3 from both sides. So that gives me negative 5x is greater than or equal to, the signs are the same signs, add the numbers together and keep the sign. 22 and 3 give me 25, so this is negative 25. Next step, Daniel, what would you do? Divide both sides by negative 5. Does someone remember the other special rule? We always want the variable term on the left. That's the first rule. What's the other rule? What happens when you divide by a negative? You flip the sign. Good job, Daniel. So we need to write a note. When you multiply or divide by a negative, you must flip the inequality sign. So we know that x is now less than or equal to negative 25 divided by negative 5 becomes a positive 5. When I think about putting this on a number line, when I put this on the number line, am I going to have an open circle or a closed circle? Closed. Am I going to, whoops, am I shading to the left or to the right? Good job. So closed circle, shade left. Closed circle, shade to the left. I need to write the number 5 right here. So it says solve the inequality and graph its solution. Well, my inequality is x is less than or equal to 5. So I'm going to go to this side. Drag this all the way in between the 4 and the 6. So there's my number line. X is less than or equal to 5. So I'm going to go to the next problem. This is problem number 4. Number 4, negative 8 minus 4x is greater than negative 16. All right, what do we want to do? Add 8 to both sides. So I have negative 4x is greater than negative 8. What would you do next, Lissandro? Divide both sides by a negative 4. Lissandro, I'm dividing by a negative. What do I need to do? Good job. Don't forget about your flip. So x is less than, a negative divided by a negative is a positive, and 8 divided by 4 is 2. So x is less than 2. Owen, am I going to have an open circle or a closed circle?
You're going to have an open circle.
Am I shading to the right or to the left?
To the left.
Perfect. So on my number line, I'm going to put the number 2 right here. Open circle, shade to the left. So in Delta Math, x is less than 2. So I'm going to come from this side and drag it all the way to the 2, and then click on the circle so it's opened. Click on the circle so it's opened. So go to the left side, drag it all the way back to the 2, and then click on the circle because you need it to be opened. Who needs more time with that one? So before we go on to number 5, I'm going to write a note. We're going to review compound inequalities. I hope that we're writing this down. Tyler, pick up your pencil for me. Come on. We're reviewing compound inequalities. You need to write that down. So a compound inequality is unique because it has either an or an and. Has an or an and. The or has a graph that goes in opposite directions. If you ask me if you could go to the bathroom or go outside, what does that mean? You need to go, you can do one or the other. Like you're giving me an option, right? One or the other. So when you see an or, it just means that at least one inequality, at least one of the inequalities is true. And, well, the and graph overlaps. It overlaps. And that's because both must be true. It's kind of like a system. Think of it like a system. When you solve a system, you graph 2 lines, right? So you graph 2 lines, and let's say that you take an ordered pair from one of the lines. If that ordered pair only works on one of the lines, does it mean it's a solution to the system? Does it have to work for both? Well, if it's a solution, it has to work for both. If it's just a point on the line, it could just make one of the equations true. It's kind of the same idea. Ors, the graphs go in opposite directions, and the graphs go together. They overlap. Ors, the graph goes in opposite directions, and the graphs overlap. So I'm going to give you an example. If I said x is greater than 7 or x is less than 5, let's graph that on a number line. We're putting both inequalities on the same number line. You always start with the smaller number first. So I have a 5 and I have a 7. Am I going to have open circles or closed circles? Those are both going to get open circles. They're both going to get open circles. What direction does x is greater than 7 go? What direction do I shade? I shade to the right. So that's what I'm going to do. I'm going to shade to the right. What direction does x is less than 5 make me shade? to the left. So I'm going to go to where x is less than 5, and I'm going to shade from the 5 everything to the left. So your OR graphs go in opposite directions. Do you see that? The OR inequality goes in opposite directions. Means that you're going to get an answer on this side, or you can get an answer on the other side. Okay? Does that make sense? Do you guys remember doing this? Okay, some of you do. Some of you are shaking your head no, like I've got horns. Okay, what about this? What if I said under the and side, x is greater than 5 and x is less than 7? X is greater than 5 and x is less than 7. So I'm going to draw my number line. I still do the same thing, put the two numbers that we're talking about on my number line. So x is greater than 7. Is that going to be an open circle or a closed circle? Open circle or a closed circle? Open. What direction am I shading? Shading to the right. Okay, I definitely encourage you to use two different color pens with this one, or a pen and a marker, or a pen and a pencil, something like that. What about x is less than 7? Is that going to be an open circle or a closed circle? Is there a bar underneath that? Open. What direction do I shade? To the left. So the solution to this inequality is the place where they do what? Where they overlap. So the actual graph looks like this. 5 and 7, both of them have open circles, and I shade the space that's in between because that is the overlap. That is the overlap. Okay? Are we good with that? You can also write this as 5 is less than x is less than 7. Okay, we've got 3 more examples to do, 5, 6, and 7. So these are going to be compound inequalities. 5, 6, and 7 are going to be compound inequalities. So example number 5. Negative 36 is less than negative 3x minus 9, or negative 42 is greater than or equal to, I wonder if that'll let me stretch that out a little bit, negative 3x minus 9. So we have to work these individually. You have two inequalities. So when I look at this first inequality, what do you want to do? We're trying to solve this one right here. What should I do first? Well, I'm going to add 9 to both sides. So when I add 9 to both sides, I have negative 27 is less than negative 3x. Are we writing this down? Some of you guys are totally zoned out. Totally zoned out. Pick it up, bud. So how do I solve that? What do I do next? You got to get up. It's over here on the floor. What do I do next? Divide both sides by a negative 3. What happens when I divide by a negative, Tim? So I have to flip. So 9 is less than x. I want the variable term to be first. Is it? No. The variable term is not first. This says 9 is less than all of the solutions. If I want the variable term to come first, I have to flip the sign again. X is greater than 9. Flip it again. When you move the variable from the right side to the left, you have to flip. You have to think about what this says. 9 is less than the solutions. That means that the solutions are greater than 9. Okay. Let's look at the other side of that inequality. What are we going to do over here? Owen.
You just add 9.
Sure. Add 9 to both sides. Yes, sir. Thank you. Add 9 to both sides. So negative 33 is greater than or equal to negative 3x. All right, Ken, what do you want to do now? I mean, this is a one-step equation. What are we going to do to solve that? How would you do that? Trying to get x all by itself. Not yet. What do you have to do to get x all by itself? Divide. We're going to divide both sides by negative 3. Divide both sides by negative 3. So 11 is greater than or equal to x. We divided by a negative, Ken. Ken, we divided by a negative. What do I have to do? Are you with me today? Are you paying attention? When you divide by a negative, you have to flip the inequality. So now I have 11 is less than or equal to x, x being all of the solutions. 11 is less than or equal to x. I want x to come first. Kenna, if I put the x first, what do I have to do? Look at the example right before it and see what we did. If I trade spots, if I move them on opposite sides, you have to flip it again. X is greater than or equal to 11. You have to flip it again. When you move the variable, you have to flip it again. So this is an OR inequality. Because it's an OR, what is my graph going to look like? Owen.
They're not going to intersect at a point, and they're going to go in opposite directions.
Perfect. They're not going to touch at all. They're going to go in opposite directions. OR is opposite. OR is opposite. So the two numbers that I'm talking about are the numbers 9 and 11. Let's look at this one. X is greater than, did we flip that again? Here. When we divided by, can you guys look at this for a second? When we divided by the negative here, we didn't flip our sign. Look, less than, we divide by a negative, we need to flip it. And then when we change directions, we need to flip it again. So fix that. We didn't do this flip. Flip, and then flip again. So am I going to have an open circle or a closed circle on the 9? Open circle. Am I going to shade to the right or to the left? To the left. Let's look at the other side. X is greater than or equal to 11. Am I going to have an open circle or a closed circle on the 11? Closed circle. Am I going to shade to the right or to the left? Shade to the right. So do my graphs go in opposite directions? Yes. So that's what we need to put here. So we need to write our inequality. X is less than 9 or x is greater than or equal to 11. It's the first thing you have to do. Put your inequality in there. X is less than 9 or x is greater than or equal to 11. So on my number line, I'm going to come from this side and take this all the way to the positive 9. Let me shrink that up so I can graph it all the way down. I'm trying to move it and it's just not allowing me. I'm trying to get rid of it. How do I make it go away? Got it. Okay. So I need to go all the way to the 9 and put an open circle. And then I need to go right here to the 11. So come back from the other side, 11, closed circle. So this is what it looks like. Open circle on the 9, shade to the left, closed circle on the 11, shade to the right. Do we have that? Yeah, you just don't have you maybe don't have it closed circle. X is less than 9, or you don't have an X here, or X is greater than 11. You don't, did you have mixed your X as well? Yes? Okay, who else got one that said it was wrong? You guys probably, when you put in your inequality, you have to name X. Okay, let's do 2 more examples, 2 more compound inequality examples. All right, so this is example number 6. Example number 6. So I have 4x plus 7 is greater than or equal to negative 13, and 15 is greater than or equal to 4x plus 7. So let's solve the first inequality. Isaac, what would you do to the 4x plus 7 is greater than or equal to negative 13 to solve it? Yeah, subtract 7 from both sides. Good job, sir. So 4x is greater than or equal to negative 20. Isaac, what would you do next? Divide both sides by 4. We are not dividing by a negative. We're not dividing by a negative. This number is not negative. So we do not flip. X is greater than or equal to negative 5. Okay. Avery, I want you to look at the next example. 15 is greater than or equal to 4x plus 7. What would you do first? Yes, ma'am. Subtract the 7 from both sides. So 8 is greater than or equal to 4x. What would you do now, Avery? Divide both sides by 4. 2 is greater than or equal to x. Avery, I want the x variable to come first. So say it again. Yeah, flip your sign to make x come first. X is less than or equal to 2. Let's talk about a number line. I have the number negative 5 on my number line, and I have the number 2. Okay. Victoria, I'm coming back to you. Am I going to have an open circle or a closed circle on the negative 5? Do you see how it has the bar underneath it? Good job. Closed. Which way does this tell me to shade? Shade to the right. Am I going to have an open circle or a closed circle on the 2, Brianna? Open circle or a closed circle? Does it have a bar under it? Closed. Okay. So remember with an and, we can actually smush that inequality together. And that's what Desmos is expecting. Negative, oops. So we write this as negative 5 is less than or equal to x is less than or equal to 2. That is how we put this into Delta Math. So, because you don't have an and up here, right? You don't have the word and. So negative 5 is less than or equal to x, which is less than or equal to 2. So on my number line, I'm going to go to 2 and negative. I really don't know how to make.
Just click on the 5 and then draw or negative 5 and draw or 2.
Just click on the -5 and it'll plot a line and then drag it. I got you. I got you. Thank you so much. Perfect. Thank you for that. I was really struggling. You're like, I know, Mrs. Bischoff, you were really struggling. Okay. So click on the -5 and then drag it to the 2. Or click on the +2 and drag it back to the -5. Are we good with that? Everybody submitted it and they got it correct? Yes, yes. Okay, we have one more example. One more example. So this is our last one, example number 7. So let's look how this is written. This says 3 is greater than or equal to x minus 7 is greater than 1. Okay. Do you guys see that you have two inequality symbols here? You have an inequality symbol here and an inequality symbol here. Do you see those? Okay. So that means that this is one inequality, and I want you to separate it. 3 is greater than or equal to x minus 7. This is the other inequality, and I want you to separate that. X minus 7 is greater than 1. Mrs. Bischoff. I do. I'll send her down. Thank you. Bye-bye. Kylie, that's for you. Okay. Now, because these are smushed together, because this inequality is smushed together, thank you so much, ma'am. It's an and, right? Because you can kind of smush together. So we know that this is an and. I'm going to add 7 to both sides of the first inequality. So I end up with 10 is greater than or equal to x. I want x to come first. What should I do? Flip it. X is less than or equal to 10. Flip. On the right side, I'm going to also add 7 to both sides. X is greater than 1. So because this is an and, what is my graph going to look like? Is it going to go together or opposite directions? Go together. I'm talking about the number 1 and the number 10. Let's look at this one. Open circle or a closed circle on the 10? Closed. Shade in what direction? To the left. Open circle or a closed circle on the 1? Open. Shade to the right. So this is what my graph looks like. When I write my answer, because this is an and, you always have the smallest number come first. 1 is less than x is less than or equal to 10. So 1, the symbol here, because we're essentially putting this first, right? So we're flipping this. 1 is less than x. 1 is less than x is less than or equal to 10. You have to put your inequalities in number order from smallest to largest. I'm going to click on the +1, and I'm going to drag it all the way to the 10. And then I'm going to go back to the 1 and put it as an open circle or a closed circle. An open circle.